All right, we're going to talk about Chapter 11. So you should be starting to read into that chapter now. And Chapter 11 is talking about probability. So there's 5 different sections that we're going to look at here. And the first one that we're going to talk about today is just the basic information about probability and how to figure out different things about probability. And so some of those concepts, we're going to talk a little bit about the history, not a whole lot. What is probability? We're going to talk about what they mean by the law of large numbers. We're going to talk a little bit about probability in terms of genetics and the term odds and what that means in terms of probability. So a lot of the information with probability was tied to gambling and was researched by Pierre Simon de Laplace. He's credited with being the father of probability, but also some of the other important people are Chebyshev, Markov, and Kolmogorov. And so these are some people that had a lot to do with it, but there are a lot of mathematicians that had information to do with probability. These are just a few. If you read section 11.1, you'll see some more names and more information mentioned. So what we were talking about with probability is we were looking at random phenomenon. In other words, you can predict if you add 1 plus 2 together, you know that that answer is going to be. But with probability, you don't know always what is the likelihood that something's going to happen. So with probability, a lot of it is experimentation. What we talk about is what are the outcomes of that experiment. In other words, what happens when we change something in the set. And all of the possibilities are called the sample space. So what we're usually talking about is some sort of event that we're doing in order to do this experiment. Like flipping a coin is the event. The experiment is how many times I'm going to flip the coin. The outcomes are what the results were when I did flip the coin. And the sample space is if I take all of the outcomes, whether are considered good or bad, and figure out the samples. So when we talk about flipping a coin, there are 2 possibilities for a coin flip. It could either be heads or it could be tails. So if I'm asking you to find the probability that it will land heads up, what we're going to do is we're going to look at the entire sample. Whoops, that's supposed to be an S. The entire sample space is, or what are all the possible outcomes. I could have a head or I could have a tail when I flip that coin. So what I'm concerned about, the event or the outcome that I would like to see happen is I want to know if it's heads up. So I want the heads possibilities. So what we're going to do is we're going to take the probability that it is a head, and so we're going to call that P of E, because E is the event that we're wanting. So P of E is equal to 1/2. So what happened here is I took the probability of all of the outcomes and I divided it by the desired probability. So what we have here is actually the theoretical answer, because as long as I flip a coin a lot of times, it's going to end up being 1/2. Now, if I only flip the coin 10 times, it might not be 1/2. But if I flip the coin 1,000 times, I'm going to end up getting closer and closer to that theoretical answer. And so that's what they talk about when they talk about the law of large numbers. The more times you do something, the more likely you're going to get that theoretical response. Okay, so if all the outcomes in the sample space are equally likely, as long as I have a normal coin and it's not weighted or not double-sided, then it is equally likely that I'm going to flip a head versus a tail. The event, E, is what I want, which is to have heads. So I'm looking at my formula is the number of favorable outcomes, in other words, what do I want, over the total number of outcomes. So there are 2 possible outcomes. I could have a heads or a tails, and the favorable that I want this time is a head, so it's 1/2. All right, so here we have a cup that is flipped 100 times. So when you flip the cup, it could land on its side, or it could land on its top, or it could land on its bottom. So I flipped it 100 times, so there were 100 possible samples of results. It could have landed on its head or its top every single time. So, that would have been 100 times out of 100. That's not a very likely possibility. So what I want to know here is, what is the probability that it will land on its top? Well, it landed on its top 10 times in this experiment. So the probability formula says, what is the outcome that you want, which is the top, divided by the total possible results, and there were 100 results. So then, of course, I want to simplify this fraction, and I get 1/10. So this is an example of an experimental or empirical probability. And again, we call it that because I actually did an experiment to figure out this result. Now, depending on the wind conditions, depending on how high I flip the cup, that experiment is going to be altered, depending on what happens. Whereas when you're flipping a coin, more than likely it's not going to be altered that much. So if E is an event that may happen when an experiment is performed, the empirical probability of E is given by the number of times that that event occurred divided by the total number of times that the experiment was performed. And that's where we did the 10 divided by 100. Okay, so there are 2,598,960 possible hands in poker. So if there are 36 possible ways to have a straight flush, what is the probability of being dealt a straight flush? So again, probability, I take what I want. The probability of being dealt a straight flush is 36 possibilities, divided by the total possibilities, which is 2,598,960. So I'm going to do 36 divided by 2,598,960 possibilities. And when I do that, I get 0.0000139. So looking at that, the probability that I'm going to deal myself a straight flush is very, very slim. Okay? All right, so a school has 820 male students and 835 female students. If a student from the school is selected at random, what is the probability that the student would be a female? Well, there are 835 females in the school, so that is my the event that I'm looking for. But when I'm looking at the total possible number of students, I have to take the 820 and I have to add the 835. So to calculate this, I'm going to take the 835 and I'm going to divide it by that total number of students. And again, that's going to tell me the probability that a female student is picked at random. And that is 0.505. So if you look at the numbers there, there are 820 males and 835 females, so we're almost split in half. So it should make sense that the likelihood that I'm going to pick a female at large or at random would be about 50%. All right, so then we talked a little bit about this earlier, the law of large numbers. That just means that if I'm conducting an experiment, the likelihood that I'm going to get that theoretical probability that I talked about at the beginning gets higher with the more events or the more experiments that are conducted. Again, if I flip the coin 10 times, and that's it, the likelihood that I'm going to get a 50% is not that great. But if I flip the coin 1,000 times, there's a greater possibility that I'm going to get a 50% heads or 50% tails result. So that's what the law of large numbers is referring to. Okay, so then we're going to talk about some probability in terms of genetics. And Gregor Mendel was an Austrian monk who did quite a bit of study with pea plants, and he was breeding the pure red plants with the pure white plants. And what he noticed is that almost always he would end up with red. So he theorized that red was dominant and that white was recessive in terms of the genes. So he came up with this information and he placed it into a chart. So if you have two parents and one of the parents is red and the other parent is white, and they're referring to the little r as being white, then these are the possible combinations that you could have. So what happens here with first generation to second generation is that since the capital R is dominant, every single offspring has a capital R in it. And so the likelihood that you're going to have a white plant was very, very slim because R is the dominant color. But when you get into the second and third generation, now you're getting a little bit more mixture because that offspring actually has a dominant gene and a recessive gene. And then the second parent has a dominant gene and a recessive gene. So when you start mixing it up there, now you have a possibility of having a white flower versus the first round, the first generation, you were probably not going to have a white flower in there unless one of the parents was not a dominant gene. So if we look at this information, if we look at the second and the third generation table, and we want to determine the probability that a third generation will be red. So here are all of our possible outcomes. We could have both of them have the dominant gene, one dominant, one recessive, one dominant, one recessive, or two recessive genes. So if I wanted to look at the probability that I would have a red flower, there are 3 possibilities where that dominant gene is there out of a possible 4. So the probability of having a red flower would be 3 to 4, or 75%. The possibility of having a white flower is 1 out of 4. So it's 25%. And that's what we were just talking about. All right, so when we're talking about the odds of something, horse racing is a very classic, football games, things like that. What are the odds of them winning, or what are the odds of something happening? It happens quite a bit in gambling situations. So when we're talking about odds, we want to look at all of the outcomes in the sample space and assume that they're all equally possible. So it is just as likely that the Redskins will win versus the Cowboys. It is just as likely that one particular horse will win versus another horse. So A of them are favorable to the event, and B's are unfavorable. So favorable means they win, and unfavorable would mean they lose. So if I wanted to look at the odds in favor of something happen, I would look at the odds of A to B. But if I wanted to look at the favor of against something happening, I would look at B to A. So let's look at this. If there were 200 tickets sold in a drawing to win a new television, if Matt purchased 10 of those tickets, what are the odds of him winning the TV? Okay, so he has 10 chances to win, but he has 190 chances to lose. So when we look at this, when we're trying to figure out the favorable versus unfavorable, 10 is the favorable event. In other words, he wins. But there's still 190 tickets out there that he didn't buy that would mean that he would lose, and those are the unfavorable events. So when I'm trying to figure out the odds of Matt winning would be 10 to 190. which is 1 to 19. So those are the odds in favor of Matt winning the TV. If I wanted to know the odds that he would lose, there would be 19 to 1. Okay, so let's look at the next one. When we're given the probability and we want to figure out the odds of something, what we have to do is first figure out the fractional probability. So remember that if you have 0.43, that's the same thing as 43 chances out of 100. Okay, so that means that there are 43 favorable or good things. So this is your favorable, and this is the total possible. Now remember, when we're doing odds, we don't take the total possible, we take the favorable compared to the unfavorable. So 43 is our favorable, so the unfavorable would be 100 minus 43, which is 57. So the favorable events to the unfavorable events. So favorable in this case is rain, and I guess that is favorable depending on the day you're looking at. And the unfavorable event is no rain. So it says, suppose the probability of rain today is 0.43. Give the information in terms of odds. So our odds, here we have here two different possibilities. The odds in favor of rain are 43 to 57, and the odds against the rain are 57 to 43. All right, so here's the opposite. What if I say your odds of completing college algebra are 16 to 9? What is the probability that you will complete the class? Okay, so completing college algebra is 16 to 9. So 16 people completed, 9 did not complete. Okay, so 16 is my favorable event. So 16 completed. Whoops, P-L-E-T-E. Okay, so 16 completed it, and 9 did not complete it. Okay, so we have 16 complete and 9 incomplete. So that means that the total number who attempted the class were 25 attempts, or 25 is our total. So if I want to know the probability, I want to take the probability of what I want, which is completion, divided by the probability, or I'm sorry, divided by the total number of attempts. So I would have 16 to 25, which is 0.64. So there's a 64% chance that you will complete the class, or there's a 64% probability that you will complete the class if you're taking college algebra. Okay? So I hope this helps. Keep up with your work. Let me know if you're having any problems. And again, I'm available on cell phone, available on text,